So today we're going to look at prime factorization. And prime factorization is when you write a number as the product of only prime numbers. So we're really mostly talking about composite numbers, rewriting a composite number as a multiplication problem, and all the factors that we use have to be prime numbers. If you have a prime number, the prime factorization of that number is the prime number itself. So for example, the prime factorization of 13 is 13. The prime factorization of 17 is 17. So the prime factorization of a prime number is the number itself. When we're talking about a composite number, however, we can take any composite number and rewrite it as a multiplication problem, and all of the factors will be prime numbers. Now, here's an example of what a prime factorization looks like. 2 times 3 times 5. The 2, the 3, and the 5 are all prime numbers, and it's a multiplication problem. So that's the prime factorization, and it's a prime factorization of the number. If we were to work it out, it's a prime factorization of the number 30. So the prime factorization of 30 is 2 times 3 times 5. Prime factorizations, we normally, if we can, write them using exponents. So for example, if my prime factorization was 2 times 2 times 2 times 7, then I really could write that as 2 to the third power times 7. And that is the prime factorization for the number 56, because 2 times 2 is 4, times 2 is 8, times 7 is 56. So 2 to the third power times 7 is the prime factorization of 56. Some things to note about how we write prime factorizations. Not only do we write them with exponents if we can, but we also write our prime factors in order from least to greatest. So for example, the prime factorization of 30, we wouldn't really write as 3 times 2 times 5, or 5 times 2 times 3, or 5 times 3 times 2. We wouldn't write it like that because we want to put the factors in order from least to greatest. Now, there are a few ways that we can find the prime factorization of a number. We're going to look at 2 of them today. One way you can find the prime factorization of a number is to do what's called upside down division. Now, we typically write the division house like this, and then we would put the number we're dividing by, our divisor, we would put out here on the outside and maybe do something like 60 divided by 5 is 12. So we might do something like that. Well, this is sort of the same idea, except it's upside down. So we're going to start with 60. And we might start with dividing it by 2 because we know 2 is a prime number. Now, the numbers we divide by have to be prime numbers because remember, we're looking for a prime factorization. So we have to divide by prime numbers. So we could divide it by 2, and 2 goes into 60 30 times. So again, this is upside down division because I'm not putting my answer on top, I'm putting it underneath. And then I continue on. Is 30 a prime number? No, it's not. So I keep dividing. So now I'm going to divide 30 by a prime number. 30 can be divided by 2. 30 divided by 2 is 15. Is 15 prime? No, it's not. So I'm going to keep working. 15 can be divided by 3. 3 goes into 15 5 times. Is 5 a prime number? Yes, it is. So that means I'm done with finding the numbers for my prime factorization. So now I can write my prime factorization. My prime factorization is going to be 2 times 2 times 3 times 5. I'm using just the numbers on the outside. That's going to be my prime factorization. Notice I could rewrite this as 2 to the second power times 3 times 5. And you might be wondering, but what if I didn't start by dividing 60 by 2? Will I still get the same answer? And yes, you will. You should still be dividing by just prime numbers. So for example, I might do that 60 and divide it by 5. 60 divided by 5 is 12. 12 is composite, so I'm going to continue dividing it. 12, I might now say, well, I can divide 12 by 2. 2 goes into 12 6 times. 6 is composite, so I have to keep going. 6 can be divided by 3. 3 goes into 6 2 times. Notice when I go back to write my prime factorization, notice that I've still got 2 times 2 times 3 times 5. So I still, or or 2 squared times 3 times 5. So notice I still get the same answer. It's just going to be in a different order, and I have to go back and then put my factors in order from least to greatest. So I'm going to give you a couple that I want you to try. And let's see how you do. Try those two and see how you do. And then when you've done them, then hit play and continue to see if you've done them correctly. So if you did your prime factorization of 24 correctly, you should have gotten 2 times 2 times 2 times 3, or 2 to the third power times 3. For 42, you should have gotten 2 times 3 times 7. Notice that for 24, I did try dividing by the smallest possible prime number when I could, and then when I couldn't divide by 2 anymore, then I got down to the 3. With the 42, I didn't necessarily bother with doing it that way, although I could have. I could have started by dividing 42 by 2, and then continued on from there, and that would have also been okay. But my prime factorization of 42 is 2 times 3 times 7. One way you can always check your prime factorization is to go back and multiply it and make sure that when you multiply it out that you actually get the number that you thought you were finding the prime factorization of. So 2 times 3 is 6, and 6 times 7 does in fact equal 42. So we can be reasonably confident that we have the correct prime factorization. All right, let's go ahead and look at 2 more. Give these 2 a try and see what you come up with. So now that you've tried it, take a look and see how you did. 13 is a prime number, so its prime factorization is just 13. For 45, you should have gotten 3 times 3 times 5, which can be rewritten as 3 to the second power times 5. So upside down division is one way that you can do prime factorization. And however, it's not the only way. There is another way that you can do it. You can do what's called factor trees. And I've given you the steps for factor trees, but I'm going to explain it as well because it's kind of a lot of information. Let's do this best with an example. So when you look at this, if I'm going to use factor trees, the first thing I want to do is break the number down into a factor pair, meaning any multiplication problem. It doesn't matter whether they're prime numbers or composite numbers, but break it down into a multiplication problem. Don't use 1 because 1 is not a prime or a composite number, and really it doesn't actually help us to break the number down anyway. So in the example I did, I used 4 and 6. So 4 times 6 is 24. And step 2 says circle any prime numbers. Well, neither 4 nor 6 is prime, so I'm going to continue. Then I'm going to keep breaking down my composite numbers. So 4 I could break down into 2 times 2. Those are both circled because the 2's are prime. 6 I can break down into 2 times 3. And since 2 and 3 are both prime, that's why they're circled. So notice for 24, I'm going to get 2 times 2 times 2 times 3, which can be rewritten as 2 to the third power times 3. Now, we've already done 24 once. We did 24 earlier when we were looking at doing it with upside down division. So if we look at that, if we go back and look at that for 24, right here we got 2 to the third power times 3, just like we got here when we got 2 to the third power times 3. You might have been thinking, well, I wouldn't have broken 24 down into 4 and 6. I would have done it as 3 and 8 or as 2 and 12. Well, let's look at that and see if those would work as well. Try it yourself. See if those ways are going to give you the same answer that we got when we used 4 and 6. Okay, so if you have done your factor trees correctly, you should have something that still ends up giving you the same answer. Now, you might not have broken yours down exactly the same way I did, but you should still get the same answer. When I broke it down into 3 times 8, I still ended up with 2. Sometimes I use a check mark to make sure which factors I've written, times 2 times 2 times 3, which is 2 to the third power times 3. And for the breaking it down as 2 times 12, notice I still am going to get 2 times 2 times 2 times 3, which is still 2 to the third power times 3. So no matter which way I split up my numbers to start with, I'm still going to get the same answer regardless of which way I do it. I still should get the same prime factorization. Let's try just a couple more examples and see if we've got this down. So try these two and then check your work. So let's take a look and see how you did. For the 90, you should have gotten 2 times 3 times 3 times 5, which is 2 times 3 to the second power times 5. You may not have done your factor tree the same way I did, but if you didn't get the same answer I did, that means you did something wrong along the way. So go back and check your work. For 72, I split mine up as 8 and 9, and then you can see how I finished out my factor tree. Your answer you should have gotten is 2 times 2 times 2 times 3 times 3. And then when you wrote it with exponents, that's 2 to the third power times 3 squared. If you did not get the same answer I did, go back and see if you can figure out where you made your mistake. So now you've had a chance to learn all about prime factorizations, and we'll continue using those ideas a little bit as we get into GCF and LCM.